In this lesson, we're going to show you an application problem that uses a system of two variables with two unknowns to solve the problem. And the particular application that we're doing here is a money value problem. So let's take a look here. It says that Zoe bought burgers for $3 and sodas for 50 cents. And that clues us into the quantities that we're going to be looking at, probably are related to burgers and sodas. And then the second sentence says the number of sodas was 3 less than twice the number of burgers, and the total cost was $34.50. How many of each was bought? So what we're looking for, how many of each was bought, means how many burgers and how many sodas. So I'm going to assign sensible variables to each of those quantities. I'm going to let S be the number of sodas, and I'm going to let B be the number of burgers. And next what we want to do is to make equations. And so when we first look at that first sentence, we've got prices on those items, but we don't have a total cost in the first sentence. So I'm going to leave that alone. But I'm going to translate this phrase here, which we can translate almost word for word. So the number of sodas, that's S, was, we can say is or equals, 3 less than twice the number of burgers. So twice the number of burgers I'm going to write as 2b. And then 3 less than that means subtract 3. So that's our first equation. Now the second equation is related to the money amount. And what we see is the total cost was $34.50. So that's going to be the amount of money that was paid for a certain number of burgers, and then adding to that the amount of money that was paid for the sodas. So if each burger is $3, the amount of money that we pay for all the burgers is 3 times the number of burgers. So that's the money value of the burgers. And then we want to add in the money value of the sodas. We've got 50 cents for each soda, but then we're going to multiply that times the number of sodas. So I've got 50 cents, and I'll just drop the trailing 0, but then we're going to say 0.5 times S. And that total amount of money is going to add up to $34.50, which again I'll drop the trailing 0. So now we have a system with two equations and two unknowns. We have S and B and S in the second equation, and we can either use elimination or substitution. Now, because this first equation has S isolated, this is very sensible for using substitution. And so what we want to do is everywhere that we see the variable S in the second equation, we will plug in the value that we've assigned based on that first equation. So we're going to rewrite that second equation, 3b plus 0.5, and now instead of writing times S, we're going to write in 2b minus 3 is equal to $34.50. Now simplifying the equation, we've got 3b plus 0.5 times 2b, so 0.5 times 2 is going to give us 1b, which we can just write as b, minus 0.5 times 3 is going to give us a negative 1.5, is equal to 34.5. And so combining our b terms, 3b plus 1b is equal to 4b. And then adding 1.5 to both sides, we end up with 34.5 plus 1.5 gives us 36. And now we can solve for b by dividing by 4. And we get that b is equal to 9. And if we go back to our key from the beginning, we said that b is the number of burgers. So I'm going to write here that we got 9 burgers. Now, to solve for S, the number of sodas, And we can use this equation here, where S is isolated, and plug in for B. So we've got S is equal to 2B, so that's going to give us 2 times 9 minus 3, and that's equal to 18 minus 3, which is equal to 15 sodas. So we have now answered the question, how many of each was bought? We've got 9 burgers and 15 sodas. And if we want to go back and check, we can. So we would plug in for S and B. So S is 15 and is equal to 2 times B, so 2 times 9 minus 3, and is that correct? Well, 18 minus 3 does give us 15, so that first equation is good. And then the second equation, we have 3B, so that's 3 times 9, plus 0.5 times S, so that's 0.5 times 15. And is that equal to 34.5 or 3450? And when we check our answers, we've got 3 times 9 is 27, plus 0.5 or a half of 15 is 7.5. And yes, that is equal to 34.5. So our second equation is good, and we have our solution. B is equal to 9 burgers, and S is equal to 15 sodas.